be talking about a lesson on multiplying rational expressions. We're going to use some of the strategies that we learned in simplifying rational expressions in previous videos to help us out. So multiplying rational expressions is very similar to multiplying fractions. So let's say we have a fraction a divided by b times c divided by d. One of the things you learned when you talked about multiplying fractions way back early on in your career is that we can multiply the numerators together and get AC divided by multiplying the denominators, BD. And once we had that, we could then reduce or simplify common factors in the numerator and denominator. We're going to look at that strategy as well as the second strategy that some of you guys might find even better. So, taking a look at this first problem here. We have 4p squared over 10 divided by 5p cubed over 4p. So, using this idea of multiplying the numerators together, 4 times 5 is 20. P squared times p to the third is p to the fifth. Over 10 times 4 is 40 p. And then what we can use is the strategies that we saw when we were simplifying rational expressions. Look for common factors. Well, what divides into 20 that also divides into 40? 20 does. So 20 goes into 20 once. 20 goes into 40 twice. And when we divide two things with the same base, we subtract the powers. So 5 minus a power of 1. So we cross out this p, cross out the p to the fifth, and we're left with p to the fourth. Now, this crossing out can be very confusing, so you have to be very, very organized and neat. Be careful of this. So what do we have left? 1 p to the fourth, or p to the fourth. Oops, let's neaten that up, because that almost looks like a 9, doesn't it? So, p to the fourth divided by 2. And that's our answer. Another strategy we could have used is right from the beginning. Let me rewrite this for a moment. Different color. 4p squared over 10 times 5p cubed over 4p. Since we know this is all going to end up together, we can treat this entire numerator, even though they're two numerators, as one. So when I'm looking at this, I see that this 4 and this 4 cancel out. And this 5 will divide into that 10 nicely. So I can cross out this 5 and this 10 and just put a 2. This p will divide into either one of these p's. I'm just going to divide into one up above. Or p takes out one of the p's here and we're left with p squared. Now again, be careful. We have a p squared and a p squared, which gives us p to the fourth, and all over a 2 in the denominator. And you see we still get the same answer. So you can simplify first and then make the fraction, or you can make the single fraction and then simplify first. As you do these, you'll kind of find which way you'd like to do the best. So let's take a look at number 2. Here we go. We have this entire two fractions being multiplied together. Now, eventually, all the numerators are going to go together. You notice how each one of these is already factored, which is nice. What we can do, here's a little trick, is we can make this fraction bar go all the way across. And now, guess what? It's one fraction. Not very neat line, but one fraction. Now, anything that's on top can cross out with any common factor on the bottom. So I see I have a group of x minus 2 that can cross out here and here. I have an x minus 9 group that can cross out here and here. And there's nothing left on the denominator. It doesn't make it 0, it makes it a 1. So we have a 2 right here on top, and an x minus 4 left over. So 2 times the quantity of x minus 4 all over 1. And we don't like to leave a denominator 1, so we'll just write it as 2 times the quantity of x minus 4. You might see some books or some other teachers at some point say maybe distribute through for a final answer, but this factored answer is just nice. Let's take a look at some more complicated ones. When we look at this, I see, you know what, we might now need to factor some of these. So, some of the problems you're going to need to factor first before you can cross out. I can't cross out this 6n with this 6n squared, because remember, we learned in the last video that we have to factor wherever possible. So I see a common factor of 6n that can factor out. So 6n, what times 6n gives us 6n squared? Just n, plus, what times 6n gives you 36n? 6. So we took out a common factor of 6n. The bottom has no common factors, so that's just n plus 6. I like to always just put my groups in parentheses to remember that that all goes together. Times 8 is just a monomial. We leave it as a monomial. And the same thing with 6n is just a monomial. And now we can start crossing things out. So the n plus 6 is a common group on the top and the bottom. You can only reduce common factors that are in the numerator as well as the denominator. 6n is also a common factor, which crosses out. And truly, the only thing left is 8. So this whole multiplication problem simplifies all the way down to 8. One more to do. Again, I see lots of quadratic functions here and things that we might want to factor first. So let's see if we can hit that first. V minus 7. Nothing to do with that. No common factors. It's a binomial. It's not a difference of two squares. So we're just going to write it down. On the bottom here, we have v squared minus 6v minus 7. We have that trinomial. Okay? So we're going to use our little strategy here. We need two numbers that multiply to give us negative 7 and add up to give us negative 6. What works? Negative 7 and positive 1. So this trinomial will factor into v minus 7 and v plus 1. Times, here, we got another trinomial. We need to factor it. So let's try this strategy over here. Two numbers that multiply to give you negative 50, but add up to give you positive 5. What works? Well, 10 and negative 5 do. So this factors into v plus 10 and v minus 5. Now on the bottom, it's not a trinomial, but I do see that we can factor out a GCF. So we got 40v squared minus 8v cubed. I know that 8 goes into both of those, so I'll take out an 8, as well as v squared. When I do that, I have 5 minus v. Now looking at this, it looks like we're all done. I see a v minus 7 we can cross out. But wait, is v minus 5 and 5 minus v the same? They're not. They're opposites. So there's a little trick to that. V minus 7s are common, but 5 minus v and v minus 5, they are opposites. Well, let's think about this. When you divide two numbers that are opposites, what do you get? Negative 1. Negative 8 divided by 8, negative 1. So anytime you reduce two things that are opposites, you're left with a negative 1 factor. And I always like to put it on the numerator. So let's think about what's left. We have a v plus 1. We have a v plus 10. We got a minus 1 factor now, and an 8v squared. So our final answer, always put monomials first, so that negative 1 times a v plus 10 all over 8v squared times v plus 1. Again, watch out for this situation happening. Occasionally it does. Okay? If it was v plus 5 and 5 plus v, addition is commutative, which means the order is the same, so you could just cross those out. But with subtraction, v minus 5 and 5 minus v were opposites. And when you cross out opposite factors, you're left with a negative 1 factor. Hence, that's why we have to have this negative 1 here. And that is our final answer. In the next video, we'll take a look at dividing rational expressions. Hopefully this helps you out, but if not, please don't forget you can seek out help from your teacher.